Okay, and we are about the hour. So my name is Gustavo Schunemann. I'm a professor at the Department of Veterinary Preventive Medicine, The Ohio State University. Welcome, everyone. And today we are going to talk about water intake for optimal pre-wean calf development. I will try to convey a few practical concept on how to promote feeding behavior and the most important, water intake, because at the end of the day, the pre-wean calf development really depends largely on water intake for average daily gain or body weight gain. With that, and so we know that the replacement program, the success, if we want to define a replacement program as a successful lactation cow, it really depends on growth, and most of the growth, the critical growth, because of the epigenetic effect later on in life, it depends on the first 60 days of life. So it matters from birth to calving for replacement female cows, but the most important is the first 60 days of life. And these are data on grazing systems, but very similar data on confinement system. And what it shows us that if these pre-wean calf do develop, in a matter, as measuring average daily gain, and in particular, if they reach the goal of developing, doubling birth weight, meaning in the first 60 days of life, they will produce for life about 5 kilos of milk per day as a cow, right? So we know that the first 60 days of life, it really matters for lifetime performance. But now, how is this related to water intake, and body weight gain, for that matter? So this is data that I've been collecting with some of these replacement heifers programs that I've had the opportunity to work with, and you can see here, one of the ways to monitor, how pre-weaning replacement program are performing is by looking at the ratio between birth weight and weaning weight. And this particular data that I'm showing here is the ratio, right? We are looking at, because we know based on science that they need to develop these, they had to be doubling, birth weight in the first 60, or at least doubling in the first 60 days of life, right? Each one of the dots represent, a pre-wean calf, right? So, and as we can see here, there is a little over 1,200 and over a year. And you can see that, on average, they are about, 730, kilos, 0.733 kilos a day. And the ratio is about 2.23. So in general, this is, a pre-wean program that is performing quite well. And there is less than 10% of them that are not doubling for multiple reasons. Some develop diarrhea, some other has some other issues at calving, and that it affects their performance later on. So I'm going to go over a little bit more in detail on this from the perspective of water intake, right? And in particular, when we are feeding this calf meal replacer, and some of the issues associated with meal replacer is the osmotic pressure, or what we know as the osmolality, right? How much osmotic pressure some of the meal replacer has, and the impact on gut health, right? So we know that here is an example. A 45 kilo or 90-pound kilo calf, they are about 75% water. So we know that water intake is crucial, right, to process, the feed, and then also for all physiological process. We will dive in now into this water, and inside this bucket, we have, at the naked eye, it's very difficult to see either bacterial contamination or mineral composition of the water. So I will expand and develop a little bit better on our understanding of what means water quality and how important is that, right? So using the example that I just present, that, doubling birth weight and that ratio and those 1,200 calf. Here is an example of, what it takes, what are the nutrients needed to achieve the goal, to achieve that, ratio of at least 2, right? That birth weight or weaning weight divided by birth weight, right? So here is an example of birth weight, in kilos, 38 kilos, weaning weight of 82. I'm just using an average from one of those calves that I have in the data set, right? And here is the average daily gain. So these are how much weight they gain in about 60 days, right? And this is the average daily gain on a daily basis. So in 60 days, they were able to gain that much weight, right? So in this particular case, they were using meal replacer. Here is the percentage of protein and fat for the meal replacer. So they were using about 48 kilos of the powder in about 60 days. Out of, that 48 kilo has to be diluted, in water. And and water, they could be the mineral composition, could be driving the osmolality one way or the other. So I'm going to show you now how that works. So they ate about 36 kilos of starter, that much. So there is some free choice water that we were able to measure in this particular calf. It's about 210 kilos or liters, if you want. So the total water intake, it comes down to about 520 kilos. So in a way, we know that water, to be able to gain 44 kilos or about 80 pounds or over like 90 pounds, right? To be able to gain that much, the calf has to drink water, right? So we will see now where that water comes from. Most early on in life will come the majority from the milk or meal replacer, but also from free choice water. There is no model to predict free choice or free water intake. It's not available. And in the newly released NASEM. And but we estimated that it's going to be somewhere, especially for the first 2 weeks or 3 weeks, it's going to be somewhere between 1 and 2 kilos a day, right, for the first 20 days. And they will increase substantially as they, start eating the solid feed. It will trigger, it will increase substantially the water intake. And this is important because most of the things that we see, in a practical way, there is no increase in starter intake and the solid feed because they're not drinking enough water. So which one comes first? It's like the discussion of the egg or the chicken. So the calf has to have water to be able to eat, the solid feed, right? So in a summary, what we observe for this data set is for every 1 kilo birth weight, body weight gain, no birth weight, the 44 kilos, the birth, from birth to weaning, the calf will need about 12 kilos of water. So this is a substantial amount of water in a very short time period. And this is just the average. So that changed quite a bit, whether we are in the summer, right? And especially in the, those areas where they are more exposed to the heat stress and prolonged, summer period versus the winter. So in the winter, we have similar issues with water intake, but it's the complete opposite, right? It's just too cold, and calf don't like to drink, cold water, right? So the first things that we look at this is what are those, calf eating and drinking behavior that are driving, early on in life. So the first 3 days of life are key for survival, right? And that really depends on the team on the farm to recognize which one of the calf can drink on their own, right? That were, early on the first week, if they rely heavily for their water that comes either from the milk or the meal replacer. But later on, they will start picking up the free water intake. So predictor for feeding training, meaning in a way, those that need assistance early on in life, those are, it's a parity effect, calf born from primiparous versus multiparous cows. So the primiparous may have a little bit more of an attention or need, right? There is a sex, a factor there. So bull calf will more likely need assistance early on, right? A dystoxic birth, and that is also confounded with parity, right? And those calves that are born backward, right? And they might need also assistance early on in life to be able to get, to this, pick up on this feeding behavior. Twin pregnancies, similar to the other, confounded with some of these calving difficulty. The summer effect, especially those, pregnancies that are at the end of the pregnancy, the cow is, calving during the summer. And associated with summer effect is those calves that are born from short gestation cows, right? The short gestation cow and Holstein cow, gestation length goes from 254 to 298, right? The short gestation is almost always an issue. It's an issue for the cow, and it's an issue for the baby calf, right? Those are it's about, under normal conditions, should not be more than 9 and 12% of the total calvings on a yearly base, but it could change. In the summer, it could go up to 30%, right, or 20%. And we need to pay attention to this because they cause some noises in our replacement program, right? It causes issues early on because it affects some of this feeding behavior, and it could be triggered by a number of things, the short gestation. It's usually something pro-inflammatory in pregnant cows, right? It could be mycotoxin in the close-up pen. It could be the summer effect, like I did mention here, so because it's pro-inflammatory. Twin pregnancy is the same. Usually they cause short gestations, right? And so there is a number of things that are associated here that we need to keep an eye on, and that it really makes the difference, in the group of people who are the ones leading or taking care of these pre-weaned calves. I'm not going to discuss the feeding programs or what is one or other alternative for a feeding program, but in general, I'm going to describe the overall feeding program because I think it is important for water intake, right? To understand the water intake, and to also understand some of these osmolality, the high concentration in our solutions. So basically, there are two different feeding programs. One is that offer constant volume, right? And there is variation in total solid. We might start early on with a low concentration, and then we increase the concentration of the solution, the liquid diet, more at the end, right after the second week. And some other that is the constant solid, so it could be 13% total solid in the fluid diet, and it's what we know as the step up or step down feeding program. So a combination of these two. So there are more than one option to get this program up and running and be successful, right? In terms of body weight gain and low prevalence of digestive, especially diarrhea early on in calf, right? So here you have the 60-day program, and this is just for the purpose of showing one is the step up and step down program. And here is one of the options using a particular solution. So when we look at this, if feeding meal replacer, if the program is on feeding meal replacer, calf early on in life, especially the first 20 days in life, are very sensitive to hyperosmolality of the solution. I'll explain now in a minute what this is, right? So they are very sensitive to this, concentration early on, and later maybe it's less of an issue. It's still sensitive, but less of an issue. Early on in life is what the most sensitive they are, right? And one of the reasons, the fundamental reason is, once the calf is born, and that they are still developing this tight junction, the lining cell inside the intestine they're very fragile, and they are still connecting each other, right? So once we feed them, we have to be careful how much is the concentration of the solute in our final solution. I'll explain now in a minute. And early on, most of these replacement feeding programs, we will feed the colostrum. So maternal IgG will protect the calf for about 2 weeks or somewhere there, especially almost 2 weeks, right? And then the calf will have to produce their own IgG, their own antibody, right? So usually it's about that time, about the 2 weeks at the end of the second week is when we have most of the diarrhea, right? So it is important, for the calf to be able to produce their own antibody. They need to be growing about, half a kilo a day. They have to be growing to be able to produce their own antibody, right? So if feeding meal replacer, right, we will have to, fine tuning here. Don't go too high enough because it's very sensitive early on. And if we damage the lining inside the GI tract, then it slows down average daily gain. And the most important at the end of the 60 days, the most important for a cow life, what we learned from, as I mentioned at the very beginning, doubling birth weight. So if the calf is 40 kilos here, it has to be at least 80 kilos, in 60 days. So it has to be doubling birth weight in about 60 days. So we'll have to manage all these processes to make sure. One of the things that is important to accomplish the goal is we do feed, a fluid diet, but also we feed the solid diet, right? And the solid diet, we are expecting this calf to be about 2 kilos at the end of the weaning period, right? They are going to about 2 kilos of solid feed. And I here place a transition where I get this arrow shows the transition, meaning we are kind of stepping down on milk. And as we step down on milk, intake in starter, the solid feed, goes up substantially, right? And we do that to develop the rumen, right? But this process rely heavily on what happened early on in the process, right? So how we do all these processes, it is important for the calf to be able to eat more of the solid. And to eat more of the solid, the calf has to drink water. And that ratio is about 5 to 1. So for every kilo of a starter solid feed, the calf will have to drink about 5 kilos more of water, right? But that depends on how we do early on this. So I'm going to touch base now on this osmolality. The osmolality of, and this is particular in meal replacer, but also I'm going to give you an example in water because water is not equal. So the water changes depending on where the farm is located, right? We will dive in this osmolality that is measured in milliosmol per kilo. So that is a measurement of the concentration of solute, right? So here is an example, right? So usually, cows produce milk. The milk is about 300 milliosmol per kilo, right? And it's very similar or very close to what the blood, and blood is. So that facilitates the digestion process, and absorption of nutrient, and also the water loss. So this, milk is about 300. Drinking water, usually most of the drinking water, the good one, it could go from 1 to 50 milliosmol, but also I've seen water that has 200, right? It really depends on the water quality. It could be really, really high, only just the water, right? So most of our, when we feed milk, you are feeding an isotonic, what we call isotonic. So this is about 300 milliosmol. Below that is what we call the hypotonic solutions, right? And more than 300, this is when we start, working with meal replacer. And something that I really want to make a comment here is, nutrients are on its own, hyperosmotic. So we do need, the sugars, we do need the amino acid, we do need that. Something to keep in mind is we don't want to be too high on the hyperosmotic or hypertonic solution. So anything more than 300, it will consider hypertonic. Like if you drink seawater, right? If you're drinking seawater, it's about 1,000, right? So somewhere between 300 and 1,000 is where the problem is, right? So here I just give you something that I calculate for some clients that we work. This is a high-fat meal replacer with 7% ash, and this is the inclusion that they're using, about 130 grams per liter, right? This is the standard high lactose. There is variation in lactose content in some of the meal replacer, and it could be substantially higher, right? And the difference between these two meal replacers is because we do need water, which one of the water we are going to be using. And most of in practical way at the farm level, if you use the water that you have, there at the farm, right? So depending on where the water is, it will be the total solution, right? And something that I, definitely, caution, like we need to be careful here is when we mix this oral, rehydration solution with milk, right? Because it's easier to do it, right? Instead of doing, in a separate meal. So we just mix it with the meal replacer. And sometimes you get really, really high, 600. And this is what, we really need to be careful here when we do, some of these, rehydration solution mixed with milk, because it really causes a tremendous osmotic pressure inside the GI tract. And I'm going to explain now in a minute, how that, affect the lining, and then it affects, average daily gain and water intake, right? So what is osmolality, right? Basically, it's just concentration of, solute in a solution that is expressed in milliosmol per kilos, right? It tells us the osmotic pressure, right? And in general, some of these osmotic pressure are, there is a mineral composition, right? Trace mineral are, some of the trace mineral are very, very, don't have much osmotic pressure, but we do account into the formula. And some others, like, this one, and sodium chloride, that would be very osmotic, right? So there are sugars, which most of, milk has lactose, and the meal replacer will has also the same, but we do need them. So we need sugars, and we need amino acid, and we need, proteins. The most important here is we're going to put together a solution that is, early on in the feeding program, is not very hyperosmotic, right? To avoid some of these issues with water loss, and the calf do not want to drink water, right? So here is just an example. Milk is about 300. The blood, in general, the blood, remember, you have the intestine and the blood lining where is all the absorption process happening, right? It's about 290. So milk, the cow produces that, feed, that food for the calf that is very similar to what we have in blood. But some of the meal replacer could be 471 in this particular case, just one of the meal replacer, or 380, right? Or it could be really higher, right? Like 518. So there are different, the solution that we put together is what really matters, because this is going to interact with some of the lining in the intestine, and it's going to determine how the absorption surface is going to work, for the calf. And that will determine, at the end of the day, the average daily gain, right? So here is just a schematic representation. Early on, for pre-weaned calf, most of them, they have very small rumen, right? And the stomach is the most important, and the intestine, right? And when we look at the epithelium, the surface that is going to be absorbing all these nutrients, the rumen is very thick. It's a very, really thick, epithelium, right? And access, here is just the blood vessel. When it comes to the intestine, it's very, very thin. It has a mucus, and a very thick mucus, and then it has only one lining of cells. So if we do use a very high hyperosmotic solution like fluidide or meal replacer, then it will cause some issues here with absorption of nutrients, right? So the way that it does, this is just to, schematic representation, like whole milk with 300 milliosmol per kilos. This is just how Mother Nature works perfect. And this is just more a representation with a really high, hyperosmotic of 600 milliosmol, almost double what would be milk, right? Here is what it costs. This is so concentrated that it start, getting water out of these cells. So it goes through this shrinking process, right? It affects the ion, pump, which is the potassium and sodium, and there is a really spend a lot of energy trying to keep this osmosis in place. So the calf will have, damage to the tight junction, those cells that keep together, right? Increase the diarrhea, dehydration, and water loss. So we don't want this because this is it trigger inflammation and it trigger a process, painful for the calf, right? And it causes they don't want to eat and they don't want to drink. So we want to be somewhere in between some of these when feeding some of these milk replacers, right? So here is an example, right? I'm using whole milk, right? Because early on in life, that is how they get the water. Most, especially the first week of life, most of the water for baby calf are coming from the milk, right? So here is the osmolality of 300, right, milliosmol per kilos. So lactose is almost 60%. So, lactose on its own is very hyperosmotic. It's just only one molecule that is very hyperosmotic. Here is another meal replacer that is higher in osmolality. Lactose is, but not as much as, the milk. And this is another one that is even higher in osmolality, right? So we know that for this meal replacer, water is the critical. So I know they are hyperosmotic. Now, what I need to know is which one of the water or what is the water that I do have available at the farm, right, when I'm mixing some of these meal replacers, right? So one of the questions important is, does water quality matter, right? Does water quality matter? And water quality we can measure or assess based on mineral composition and based on bacteriology, right? Two things that are important to determine water quality. The short answer is yes, right? And unlike this study, because in this particular study, what they did is they used 3 different sources of water, 3 different sources. These are well water, well water with a mineral composition. Here is the mineral composition. This is the city water, right? They use city water. And this is well water that went through or filtrated, through the reverse osmosis water, right? So there are 3 different ways of, feeding, the calf. And they were using calf of about 100 days old with this body weight, right? And they were feeding the calf and trying to see which one they prefer best, right? So what I did here is I estimated, they didn't report in the paper, but I estimated the osmolality for this particular solution. And just to highlight how important is the reverse osmosis, because with reverse osmosis, you almost eliminate most of the minerals that we don't want in water, right? They do work, but they are expensive because they have a maintenance. So there is a cost associated with this. But we do know that the reverse osmosis process is effective, to control some of the water quality, right? So, and most of the minerals, when it comes to the reverse osmosis process, right? And these are the ones that were, significantly reduced, right? And especially sulfate. We don't want, these are very hyperosmotic, and we don't want sodium as well, right? And those are things that really matter when it comes to the solution. So there is a way for us to control some of these excess mineral and water, and they do have a significant difference in osmolality, and we are going to be mixing that with the meal replacer, right? So when it comes to sulfate, right, I'm assuming for this calculation of osmolality, that is, they're using this composition. So the ions that are, available, 100% available, SO4, right? If this is the elemental sulfur, right, we had to use a correction factor that is 0.33, because 0.33 is the one that is available for absorption, right? Not 100%. So it depends on what is measured, right? And water analysis is what you are going to have to consider. So by default, when I request the water analysis, I request this sulfate, right? The SO4, because that is 100% available. So another thing that they did is because they did a preference testing on these 3 sources of water, and the reverse osmosis water was on the top. So we do know that if you reduce some of these mineral composition in water, right, you improve substantially, right? You improve substantially water intake. Something that I did not mark here, and didn't put in a red square, but it is important. I shall realize later today, is the iron content. Iron content is this is about quite high, right? It's about the limit, right? But the reverse osmosis remove most of that, right? It remove most of that. So that is important. Iron content is associated with intake. So it has associated with the taste. It is associated with intake. But you can see here that, reverse osmosis based on osmolality was, the most high in intake, and untreated water well was the lowest, right? Something that I did calculate for this study is the coefficient of variation. So how much variation was on day-to-day based on how much they drink. So as you have high osmolality or more mineral composition in your water, especially one of these that I highlighted in red, the highest the coefficient of variation, meaning there is significant variation from one day to the next, right? And at the end of the day, what happened is the increased variation and a reduced water intake. So we do know that water quality is something that we need to keep an eye on. And there is also a solution. It has a cost, but reverse osmosis helps, to control some of these mineral content. So what I did is I'm using 2 water, one single is, 2 different water quality from complete different farm and complete different stage, right? And here are the minerals that I'm using to compute the osmolality in the water, right? So here I have a good water quality, what I consider a really good water quality, and the osmolality is about 6, almost 7, right? And here is a water quality that I consider, a question mark. A question mark because this is high and really high in sulfate, right? And these are water quality, that we really need to consider an alternative because it's really, really high. And the osmolality in the water, it comes down to 55 millismol per kilo. So now I'm using a good, meal replacer. It is a little high in the osmolality, but this is a good meal replacer. It has very good source of protein and fat, right? And but it depends on what the water that I'm using, right? When I'm mixing with a good, if I go to this particular farm, this meal replacer will perform without major problems, right? But if I had to use it in this particular farm, the meal replacer is almost to the maximum, right? Because I'm adding the water to the same meal replacer. So this is 455, 450. I'm going to show you now in a minute. It's kind of a threshold based on the data that I collect through the different paper, when it comes to the osmolality. That doesn't mean that if you got 460, you will have a problem, but increase the osmolality, you have to think about it, risk. And the way you have risk is the higher the osmolality, the less margin of error you have. You have to do almost everything perfect, right? And it's at the farm level, it's very difficult to work when there is no margin of error, right? So it is important. What I know is that the water quality is what really matters, even when I have a good meal, replacer, right? So what I did to kind of, a threshold for osmolality has not been established, right? So what I did is I collect data. Here is one of the papers that I collect data is here on the left side of the slide, right? And then I ran an analysis. I did the predicted risk of gut permeability, right? So I took all these data from this study and I ran a risk analysis just to, come up with the cutoff point for this. And here is what I find out about doing this. Usually these are safe. Anything below 450 is usually safe, right? It's safe and there is minimal risk. We cannot eliminate the risk, but it's very minimal risk. When you are you're between 450 and 550, that will definitely trigger. Based on the data, it will trigger, and then there are different studies that assess that permeability. When increase the permeability, meaning some of these molecules can be absorbed and show up in urine. So definitely trigger stress in the lining of the GI tract, and you had to monitor gut health, right? Very high risk to monitor from 450 to 550. Right. Once you go through this 550 threshold, this is a high risk zone, right? And I personally do not recommend it's too high and there is too much risk to have this osmotic diarrhea. This is not infection per se, but it's because of the osmotic pressure we are causing some of this diarrhea, like I showed here in the picture. So I'm going to switch now and talk about some of the major factors that are associated, with water intake. So in this particular one is what is the effect of water temperature on water intake. So young calf, especially early on, they cannot thermoregulate very well, right? And they are very sensitive to both cold and heat stress, right? In general, they prefer to drink, water which is warm, closer to body temperature, the calf body temperature. So anywhere between, closer, like I highlighted in red, closer to 35. Body temperature in calf is higher, about 38. And so they do prefer that. And here is an experiment when they warm the water from 8 to 18 Celsius, that increase water intake by, free water intake by almost 50%, right? And another important concept here is because you can measure the ambient temperature, but the wind chill is very important for calf. They are very sensitive to this one. So housing became something important for when it comes to water intake, especially in the winter month, right? Drinking behavior, they spend about 30 minutes a day drinking. They drink very quick. I mean, it's not like they spend 3 minutes drinking, but usually each bout associated with drink is about 3 minutes in length, right? They do prefer open buckets, right? This is important when you have to design, water or access to water. And based on this behavioral research, calf has some sort of difficulty. If you have some of these automatic nipples, right? They don't know how to, get access to the water. So you have to, be mindful when you set up some of these facilities and design access to water, understanding some of this behavior, because this is important. We don't want to be limiting, a water intake. The summer effect is also another important. So I just covered the winter. The summer effect is important. Calf do want warm water, right? And they are both sensitive to pre and post weaning, temperature humidity index, right? And we do have to offer early on, the first week of life, unlimited access to clean water, right? Something important that I got it from this, this is a good facility where I think they have, controlled most of the issue, especially in the summer and winter when it comes to water intake, right? They provide shade, to those hatches, under the roof. And they do provide ventilation in the summer, they at the calf or the hatch level, so for air movement. And this is an interesting study. What they do show is, you don't have the temperature humidity index Well, there is a strong correlation between this temperature humidity index and the neck temperature. So if you take the temperature in the neck, right, the correlation is 83, so it's highly correlated. What that means is that at the farm level, we can just take the temperature and get an idea whether or not they are under heat stress, right? And we know that under heat stress, that will, significantly increase their water intake, but also affect their behavior. They don't like to eat and they don't like to drink, the same as the cows, right? And the most important is as the day, they don't do that during the day, but they completely behave different during the night. So during the night, they do have to have access to water because this is when they are more active, right? Water intake is strongly correlated with, solid feed intake, right? There are several studies on this. This graph is just only one of the studies. But in general, free water intake will range between 0.75 or 1 to 2 kilos a day. These are free water that are not coming from the meal replacer or the milk. This is on top of what we already feed in the fluid diet, right? So early on, for the first 2 or 2.5 weeks, it comes, there is some water intake, low, but there is some water intake beside what we feed in this fluid diet. And as the solid intake start taking off, right, then the water intake, it really goes up. It almost double, right? It's almost 4 or 5 kilos of water for every kilos of feed intake, right? And this is important. And I think the success of some of these replacement programs, like I showed at the very beginning, that they have more than 90% of their female calf, that they double birth weight in the first 60 days of life, it's because they manage this process very well, right? They manage access to water, they are feeding enough water, to promote a solid intake, and that helps them to develop the rumen. Right, the rumen is the most important because before weaning, before we get to the day 60 and weaning, for those that are weaning at 60 days of age, we had to have a functional rumen that be able for the calf to, process solid feed. They are not anymore on a fluid diet, right? So, and this is, I really like this picture from Dr. Hendrich, and that shows, what it looked like rumen development. So we had to develop the rumen, the papilla, because those are the epithelium that are going to be responsible later on for most of the fermentation and the process, the absorption of nutrient, right? Another concept important that I've been looking at later is the effect of how we do the colostrum management. So in this particular study, they all have the same feeding program, the same meal replacer mixed with the same water quality, right? And here is something that caught our attention is the difference of feeding once versus 2 meals of colostrum, right? So you can see here the probability of diarrhea, right? These are just the probability in the first 60 days of life of developing diarrhea. So for those calves that we fed twice colostrum, right? We fed about 10% of body weight in the first hour of life, and another meal of about 2 kilos or 2 liters of colostrum about 6 to 8 hours later. We reduced the probability of developing diarrhea by 50%. So, and remember, mortality and average daily gain depending on diarrhea. When you look at, that most of these calf will have to develop every day that the calf has an event of diarrhea, it slows down their growth, right? So by feeding these 2-time colostrum, we remove the risk of developing diarrhea by 50%. And as you can see, something important to look at in this graph, right, is that most of the effect of feeding twice colostrum is early on in life, right? It is within the first 2 weeks, right? Once we get to 20 days, it doesn't matter. It's the same. So because diarrhea is within the first 2 weeks, most of the cases, right? But also, I think what it is here that we are diving more into it, that is by feeding twice calostrum, I think we are strengthening, in a way, the lining of the epithelium, right, in the GI tract. And it really helps for the calf to, handle a little bit more, because they are very sensitive to this hyperosmotic pressure early on, especially the first two weeks of life. They are much better. They can handle much better some of those issues associated. Definitely they have immunity, right? But also is that interaction between the liquid diet and the lining of the intestine would also matter when it comes to diarrhea. So what happened in some of these studies, what we observe is definitely for those calves that develop diarrhea, they are experiencing more pain, and pain is negative with dry matter intake, dry matter or water intake. So definitely it affects those intake, and then later on, that is why we don't see them developing well and in terms of average daily gain. So what is the effect of hygiene on water intake? Here is interesting studies that look at the hygiene and how we sanitize all this equipment, from the bottles or nipples to bucket, right, or water trough, right? So daily sanitation is what really matters. And I'm saying this with a great deal of caution here, because I know they take labor. It takes people to do the work at the farm level, right? But daily cleaning sanitation really matters, right? Because it's associated with reduction of the bacterial contamination, it increased water intake, and because you increase water intake, they eat more solid, and they gain more weight, right? And in this daily cleaning, the most important is, you gotta replace the water, but also you gotta do this, scrubbing with a brush to, hot water and detergent and a sanitation solution to be able to get, remove most of the bacterial load, right? You can measure water, right? Your solution from the well, and there is two ways that you can do it. The ways we do it is we get a sample from the well, and we also get a sample. The first one is from the water trough. The water means where the calf are drinking the water, right? But if there is too high contamination, you want to know also if the well is contaminated. So sometimes you have one well, and that well is feeding different group of animals. So sometimes if the well is contaminated, several groups are going to be contaminated, and you just want to, or whether the contamination is only at the calf level. So you just need to figure it out where the contamination comes. Most of the time, it's at the calf level. But it could be that the well, depending on the year, it could be the well that is contaminated. So pH has to be about neutral. There is a range there, right, and pH. The mineral composition, there is a number of minerals that you can, request. I just highlighted some of the most important, sodium, cows tolerate more. When it comes, lactating cow will tolerate higher concentration, right? And sodium, what you want to have it, remember the two water analysis that I show you, one of the ones that I consider water A, that was very low in the mineral composition, and then there was another water that has really high mineral content, right? So chloride, another important, the sulfate, this is definitely important, because not only is osmotic, but it also causes some other issues with the calf. It reduces the absorption of important trace minerals like copper and selenium, and then it affects their body weight, gain. So it really has, if it is too high, like the water B that I show you in my presentation, they cannot absorb orally those, right? And there are some other, like nitrate. This is important because it associates with some of the E. coli. It could be contamination in your well, and it will show you, and these are also hyperosmotic. There are trace mineral and some of the heavy metal, right? And the heavy metal, this is arsenic and cadmium. And usually there are it shouldn't be probably it shouldn't be present in water. And but some of the farms, they want to know some of these, water quality, what they are feeding to these either lactating cows or baby calf. When it comes to the bacteriology, there are basically the two most important is total coliform and E. coli, right? E. coli has to be free, right? They have to be free from contamination. Total coliform, because not all are bad, or they are part of, they may come from the well. And here is the limit. It's environmental contamination. If it is higher than that, E. coli should be 0, Salmonella none, right? And lepto, this is important, only lepto when we have some abortion problem or low chronic conception rate, right? And we kind of know now that some of the, heifers might have drinking water from different ponds, and that pond is contaminated with lepto. Once they get the lepto, they get inside the kidney and they stay in the kidney, and that causes these two problems: low conception rate, right, or abortion problems. And it's almost always come because of the replacement program. At some point, these heifers were drinking water from this pond, right? So when it comes to hygiene, there are different ways, practical ways to do it. This ultra snap swab test, they measure, mitochondrial ATP, right? And there is one in general for contamination of surface, like when you're cleaning the equipment. And this is part of our quality control at the farm, just to look how, how the cleaning process is done. And also there is a more of the recent version that also come to measure E. coli. And this E. coli is specific in water. So you could test in water. It takes longer, a little longer to get the data, but you could do this with the same, with the same device, right? And so sanitation is crucial for the process, from the maternity on, right? Because that really mattered on water intake, especially because contamination in the environment is very likely you end up with contamination in water. So the take-home message here is that we need to be aware of some of these calving-related events affecting feeding behavior, especially the prepartum and at calving that affect some of these feeding behavior. There is preference to drink warm water, right? And also we need to be aware that for every kilo of solid feed, the calf will need to drink about 4 to 5 kilos of water. So without water, very difficult to get the solid feed, and without the solid feed, it's very difficult for the calf to meet the double birth weight in the first 60 days of life. Cleaning and sanitation is very important because it also E. coli, when E. coli is high in this water contaminated, it causes inflammation in the GI tract, and it causes also a delay or slow down the growth of the calf. Offer a Libitum water, as soon as possible from day one, right? And usually this water is what drive, starter intake, it promote health. And once we have health and starter intake, we promote the rumen development. And what this is, this process, what trigger is, that average daily gain that we need, from birth to weaning, but also after weaning to keep growing until calving. With this, I'll stop right here and take any question, the group may have. Thank you very much, everyone, for staying in the webinar. So feel free now to